and we'll get going. Okay, let me share a screen with you. Okay. All right, so can everyone just hear me? Just say hello to me, just so I know you're there. Hello. Hello.
Hello.
Hello. Hello.
Yes, we're here. I'm here.
Oh, great. It's good to hear your voices.
Hello, Professor. I'm here.
Oh, good. Good to have you. Okay, cool. So I have, all right, hold on one second here. I'm being distracted by somebody. Okay, sorry about the delay. Of course, no one need my attention until I started up teaching again. Then a kid runs in, one of my own children who needed something. So what we're gonna do now is we're kind of gonna put all this stuff together into like trying answering questions that might be applicable in some way to real data. So there's two problems here. I guess I'll do this one. There's one about IQ scores, as I mentioned that earlier in the lesson. So this problem is in your document. So if you were to go down in this week's notes, this is week 3, management 610, you will see something, a problem 54 called IQ scores. So you can go to that question there. And let's see what happens. So IQ scores on the Welsher Adult Intelligence Scale for 20 to 34-year-old group are approximately normally distributed with a mean of 110 and a standard deviation of 25. So just so we're clear, this is telling us what the average is, and this is telling us the standard deviation. And so this is a little bit weird because all the problems we did before our break, we had things like we had a normal distribution table and we had z-scores. We did not have any real numbers that represented anything in the real world, like heights or anything else or something like that. Okay, so let's try and make some sense out of this question. So look at the first question, part A. At what percentile, they're asking us, it says right here, at what percentile is an IQ score of 150? So let's go draw a normal distribution picture for this and see what our issue is with this new question. So here's our normal distribution. Every so often my Microsoft Pen gets a mind of its own. I haven't figured out why yet. So here's our normal distribution. We know the mean is 110. So we're going to put mu equals 110 in the middle. A little hint for what's about to happen. We know that z equals 0 goes with a mean of 110. Okay. The question asked us, at what percentile is an IQ score of 150? I don't know if you guys think that's a good IQ score or not, but it actually is. So we know our X value is 150. This person's IQ score is 150. And if they're asking for the percentile, over the course of your lives, you've probably heard the word percentile before. Maybe when you took the SAT, for example, or the ACT, when you wanted to get accepted to college, or other tests you may have taken. If any of you have kids, then you know when you take your kids to the doctor, they'll measure how tall they are. And they'll say, oh, your son or daughter is at the 50th percentile or the 30th percentile. 30th percentile, child at the 30th percentile would be taller than 30% of all other children that were the same age. If you were at the 90th percentile, that means you're really tall for someone your age. You're taller than 90% of the people that are the same age as you. So percentile means what percent of people are less than or equal to you. So if someone has an IQ of 150, we're saying how much area in the normal curve is below them. That's what it means. Now, obviously, this person's above the mean, so this person must be above average intelligence. The question is, what percentile they're at? So we know already that the only way, hold on a minute here, the only way that we're going to be able to use that normal distribution table that we used a whole bunch of times to start tonight's lesson was to have z-scores, right? We need z-scores, and we do not have z-scores. So somehow we have to be able to take this 150 and make it into a z-score. And it turns out that there's a way to do that. So here you go. Here's a new definition. Z equals x minus the mean divided by the standard deviation. So this is a formula for z-scores. This is how you find them. So this is how we take the z table and the z-scores that we looked at before and apply them to real life problems. So here we go. Ready? So z equals 150, which is this person's IQ score, minus the mean of 110 divided by the standard deviation of 25. So let's go put that in a calculator and see what we get. 150 minus 110 is just 40 divided by 25. So here we go, 40 divided by 25. And I'm getting z equals 1.60. I mean, how cool is that, right? So now we could take a problem with someone's IQ score and find out what percentile they're at. It's really pretty neat. So that's what we're going to try and do now. We need to find the z-score, what area goes below this. So let's go do that. So if I look up 1.60, so here I am. I'm putting the 1.6 at the bottom of the thing here. And you can see 1.6 and then 0.00 on top. I'm getting 0.9452. So here's what we did basically in the normal distribution chart table. We had z. We looked for 1.6. We looked for 0.00 on top. And I forgot what it was. Hold on a minute. Okay, 0.94. So when we looked here and here, we got 0.94. I think it was 52. Yep, 52. So that means that when we look up the area that goes with the z-score, we get 0.9452, which means that this green area is 0.9452. If you want to make that a percent, you can. 94.52%. So this person this person's IQ score is higher than 94.52% of all other people who've taken the same test. Okay. Any questions or comments about that? So it's sort of a big stat right after the break. This is the whole thing. After the break, this is the one new thing we've learned now. We can take problems where we're given the mean and also given the standard deviation and convert them to z-scores and then use our normal table the way we learned to use the normal table earlier. So that helps us a lot. Okay, let's finish up some other questions. Part B, what percent, so I'm looking at this part right here. Let me highlight it for you so you can see. So I'm looking right here. What percent of people aged 20 to 34 have IQs between 125 and 150? Let's draw a picture for this situation and see what we have. So an IQ is between 125 and 150. So make sure, is that what it said? Yep, okay. So here we are, normal distribution. We know the mean is 110 and that's in the middle. 125 is over here. 150 is over here. And we want this green area in between those two numbers. And if you think about it, this is really what we did earlier in the lesson. We did a whole bunch of problems like this where we found the area between two z-scores. The problem is I need to convert these to z-scores, like what z-score goes there and what z-score goes here. So that's what we need to do. Now we already know the z-score for 150. We did that in the previous question, so that's 1.6. We need the z-score for 125. So let's go get that. Z equals 125 minus 110 over 25. And if you do the math correctly on that, you're going to get Z equals 0.6. So this Z score is 0.6. Okay. So what I'd like to do is I'd like to look up the area for Z equals 0.6. I need to get that area. And I need the area for Z equals 1.6. You actually already know that. That's 0.9452. That was the question in part A, just in case you forgot. Here's the normal chart. If you look in the lower left corner, you'll see the 1.6. And right next to it is the 0.9452. So that's what we have there. We need to look up 0.6 as well. So we're going to go in a normal chart. We're going to do this. Here's what's going to happen. We're going to have this thing. We're going to have Z. We're going to find 0.6, 0.00 on top. And whatever number is right here is the number we want. So let's go do that. I'll drag the chart down a little bit. Here you go. And you can see in the lower left there that right next to the 0.6 is 0.7257. So this number in here was 0.7257. Further down, there was the 1.6, and that was 0.9452. All right. Any questions about those two steps? All right, so we're gonna have to be clever because this area, I just forgot, right? 0.7257. So this area here is 0.7257. Okay, so here's what we know. The area below 125, all of that purple area is 0.7257. The area below the 150, which is all of this, all that green area below the 150, we figured that out already. That was 0.9452. We want this red area here. So we can see we're going to take 0.9452 and we're going to subtract off that purple area of 0.7257 to get the red area. Let me subtract that for you and see what we get. So again, 0.9452 minus 0.7257. And we get that the red area is 0.2195. Okay. So any questions about that? Yes, no, maybe. What do you think? So what that's telling us is that 21, so the answer to this question was 0.2195 or 21.95% of people have IQ scores between 125 and 150. The answer to the first question was 94.52%. If you have an have an IQ score of 150, your IQ score is higher than 94.52% of all people. Okay, good. Let's do the last part of this question, the Mensa question. So we're going to look at this question here. So I don't know if you've heard of Mensa. Mensa is a high IQ society. So you can search that up on Google. Type in Mensa, how do I get in? Or type in Mensa IQ test, and they'll give you practice tests you can take. And if you score well enough on them, then you can sign up to take an IQ test that Mensa would accept. And if you do well enough, you get into their club. And I don't think it does anything for you other than maybe it's a cool thing to put on your resume, possibly, that you belong to the Mensa IQ Society. People have different opinions about it. So you might turn some people off, so be careful. But if nothing else, you would know that you could do it. So what does it mean? Well, according to this question, Mensa is an elite organization that admits members who score in the top 2% on IQ tests. So if your IQ score is in the top 2% of all IQ tests, then you could be in Mensa. And the questioner is saying here, what score would an individual have to earn to qualify for Mensa? How do we get ourselves into Mensa? What do we need to get? Well, you need to be in the top 2%. So here's what that looks like. Here's your normal distribution. Over here somewhere is a number X. And I don't know what this IQ score is. What we do know, though, is that the area above it is 0.02 or 2%. Because if you're in this little green area out here, this is where the Mensa people are. And here's where you have to realize that if this is the top 2%, then the area to the left is 0.98. Here's everybody else, 98% of the human population that is not in Mensa. Okay. So this question should also remind you of the beginning of the lesson where I asked you to work backwards, where we were giving you the area and asking you to find the z-score. So the thing I'm going to say is we actually can get the z-score that goes here, since we know the area to the left is 98%. So what we're going to do is this. We're going to go in the z-chart. We're going to try and find a number in here somewhere that's really close to 0.9800. And once we find that number, we're going to circle it. We're going to look to the top. We're going to look to the side and figure out what this z-score is. That's going to be our plan. So let's go do that. So here we go. I'm going to look in this chart, looking for 0.98, or as close as I can get it. Let's see what we got. I see a 0.9803. That seems really close. Some of you may disagree with me because the number to the left of it is 0.9798. So in the chart, I'll make a new chart. Here's what I'm finding. So if you look in the Z chart, Z, you'll see somewhere in there a 0.9798. And right next to it is a 0.9803. And so there's two numbers. There's a number above that, a number above that. And then there's another number over here. Now, if I look at it, I am seeing, I'll bring it down to the bottom here. So we look at the last row. I see 2.05 or 2.06. So here is the number 2.0, and this is 05 or 06. All right, 05 or 06. Anyone have an opinion on which number they want us to use? Okay, it doesn't matter. I would take either one here. They're both really close. Technically, this, here I'll circle this number. I'm circling in purple here. That's closer. It doesn't matter. I'm going to use the 2.06. Okay, so now what I know is back on my original question here, I can say that the z-score is 2.06. And my claim is that once you figure out the z-score is 2.06, you can solve for x. Right? That was our question mark. What's x? It's not 7. It's a question mark, by the way. So here we go. Ready? So z equals x minus the mean divided by the standard deviation. In our case, 2.06 equals the IQ score, which I don't know, minus the mean of 110 divided by the standard deviation of 25. So I need to solve this equation. All right, so let me pause for a minute. Do you have any questions about that step? Okay, so here's how you solve it. Some of you may not have solved an equation like this in a long time. So the trick is you take the 2.06 and you put it over 1 equals x minus 110 over 25. Now I could mention this as well. There's other ways to solve this. This is just a way that's going to work very easily for all of us. Ready? So now what I'll do is I will cross multiply here and here. It's called, you may remember cross multiplying from a long time ago. So 1 times x minus 110 is x minus 110. And the other side, I get 2.06 times 25, whatever that is. So let me go get that number for you. So here we go. Clear 2.06 times 25. I'm getting 51.5 on that side equals x minus 110. Final step, add 110 to both sides. And if I do that, I will get x equals 161.5. So that's it. If you get an IQ test score forgive me, of 161.5 or higher, then you could be invited to join Mensa. That's what it takes to get in the top 2%. Okay. Let me pause there. Do you have any questions for me about that problem? Yes, no, maybe. Okay. So believe it or not, that is a good place to stop, because any of the question I gave you tonight would be that question we just did in disguise. Just instead of saying about IQ scores, there's a question there about lengths of pregnancies. There'll be other problems in the homework that really utilize the same ideas as that one. So for the rest of this session, what I would have done tonight was have you practice problems. But you can do that on your own and then email me questions or things like that. And if we need to, if you want to meet next week, like for an extra help, I can make myself available. You can just come in for a question, ask me a question and go, or you can save it for the following session, either way. Okay, so let me at least wave to you and say goodbye. It was a pleasure to see you all. Okay.
Bye, Professor.
Those are hard.
Thank you.
You're welcome. Have a great night. It was a pleasure to spend time with you guys. You take care.
Okay.
You too.
Bye-bye.
Bye-bye.
Thank you.
And like I said, this session will be recorded. I'll post it later.